Okay, so here we go. We're going to do factoring by grouping today. And we're calling it pretty much what it is. We're going to see some similarities, and we're going to use that to discover a factor inside. Okay, we're going to use that similarity to find a factor inside. Yeah, we have a short class today. Thank you. Okay, factor by grouping. So here is a basic idea of grouping already. So if I give you x squared plus 3x, what do you see in common between x squared and 3x? We have a common x, right? So the idea is to look for hints of how you can factor by looking for common values. And in this case, we could factor out the x, we divide the x out, and what happens when we have, what do we have left? If I divide x squared by x and 3x by x, we end up with x plus 3. Okay, the basic idea. We can do this with variables. Sometimes we can do this with numbers. Okay, in this case, I see a common 2x and a common 2x in both. Now, you can only factor by grouping if you do have a common factor in both the terms, or in 3 of the terms, 4 of the terms. So, since I have a common 2x, I'm going to write 2x in the front, and we end up with x plus 4. Now, you always want to double check it, especially when you're starting to learn something. If I can go forward, can I go backwards? If I double check x times x is x squared, and x times 3 is 3x. Okay, just to make sure I am in the right ballpark here. 2x times x is really 2x squared, and 2x times 4 is really 8x. Okay, so these are some easy factoring problems that we saw before. It's almost like a duh, right? We kind of did this with numbers before, but here we go. Now, if I have a trinomial, what if I said it's going to be x cubed plus 4x squared plus 3x? Okay, and I ask you guys to factor this. Well, a common factor for all these, you can't see the screen. Okay, sure. Can the rest of you see the screen right now when I'm writing?
We don't see you writing.
You guys don't see me writing.
Or as at first, I was seeing it, but I wasn't sure if you were still continuing or not.
Oh, let me. Oh, I see. I think it's glitching out. Just give me a moment. Okay, we're looking at our 3 terms: x cubed plus 4x squared plus 3x. We see we have a common factor here, and let's go ahead and take out the x first, and then we have x squared plus 4x plus 3. Double checking, x times x squared is x cubed, x times 4x is 4x squared, and x times 3 is 3x. So the idea is we're looking for what's in common, and we can factor that out through division. And then one more step here is to say, hey, look, x squared plus 4x plus 3, can I factor this? And I have x and x. 3 times 1 is 3, and 3 plus 1 is 4. So we can see that this is automatically factorable. And plus plus is plus plus. So these are some skills that we've been working on already. And this is going to lead us to factor by grouping. Now, here's my factor by grouping problem. Now by grouping. Because by grouping, you'll notice that there is nothing in common in this overall problem. I see a 3 and a 2. Okay, those don't factor out. 18 and 12, those don't factor out. I see an M, M, M. Oh, no M. Darn it, I wish they all had an M. So in this problem, we're going to do something a little different. We're going to say, instead of looking at the whole problem at once like we've been doing previously, we're going to look at only in groups. We're going to take a front group and a back group. Okay, a front group and a back group. Now in the front group, I know that 3 and 2 are not in common. But how about m cubed and m squared? How many m's do I have in common? I have m squared in common, leaving me 3m plus 2. Whoops, there's no m. 3m plus 2. Double check. 3m times m squared is 3m cubed, and 2 times m squared is 2m squared. And I messed up there because of that negative sign. Oh, please don't tell me I'm going to have to change this every single day. Right? In the back, if you look at the 18 and 12, what value do I have in common? 18 and 12, 2 I have in common, 3 I have in common, but better, I have 6. So plus 6, left over 3m. Darn it, I erased it and then I went back and I rewrote the same thing. Minus, that's a minus 2, okay? Minus 2. Okay, we factor what we could from our two groups, the front group and the back group. Okay, the front group and the back group. Now, here's what I want you guys to notice, is that we both have a 3m plus minus 2 now, 3m minus 2. So we are going to factor out the 3m minus 2. Very similar to what we did before when we just factored out an x, but now we're going to factor out the whole group, 3m minus 2. If I factor out 3m minus 2, we have left over m squared plus 6. And this is how we factor by grouping. Okay. So the idea is we have common values in the front two terms and common values in the back two terms. Now, you can factor by grouping a lot of different ways, actually. You can pick the first and third and second and fourth. You could go this way and this way, but usually that's a little more confusing, so we just stick simply to the first two and last two. Okay, let's go. Yes?
I have one question. So
Yes.
would there ever be a case where one of them would be positive?
The terms have to be exactly the same. These two terms have to be exactly the same. Because when I'm factoring out, I'm pulling out values that are exactly the same.
All right.
So if one was plus and one was minus, you could not factor in them both. The idea of 3m minus 2 and 3m minus 2 is these would be exactly the same number no matter what m I use. If m was 1, that'd be 3 minus 2 would be 1. They would both be 1. If m was 2, 6 minus 2 is 4. These both numbers will be 4. So no matter what, we're still factoring out the same number. If m was, let's say, 10 even, that'd be 30 minus 2 would be 28. They would both be 28. So no matter what number they are, they're going to be exactly the same. If one was plus and one was minus, they wouldn't be the same number anymore. They would actually be different terms.
All right. Thank you.
Cool. Good question. All right, let's do another one. Let's do so we're sticking with like medium level problems. We're not really doing super easy ones. Okay, so let's do another one. Here's my next example of 25x cubed plus 15x squared plus 45x plus 27. So looking at this really large value problem, we could say, hey, man, I have no way of factoring this. But the point is to give us a little bit of a help here is we're just going to break this into two parts. The final answer for the previous problem, when I say please factor, these are the factors of my 3m cubed. So let's take a look at this next one, and then we'll actually double check this one just to make sure. Okay, so tell me what values are in common with 25x cubed and 15x squared. I see they both have a 5 and a max x squared in common. Are you guys kind of okay with that? They both have a 5 and an x squared in common. And we're left with 5x plus 3. You can double check by multiplying them back together. 5 times 5 is 25, and 5 times 3 is 15. In the back, I'm going to use a positive, so plus. 45 and 27 have a common number of 3 and 9. I'm going to take the whole 9 and no variables in between, in common. So that's going to be 5x plus 3. Now, here's the hint that should pop out already. I should see that these terms are going to be exactly the same. This is kind of like the hidden revealed part. Mysteries revealed. So because they have the same term, I can factor these out in one big parentheses, factor these out, kick this out as 5x plus 3, and we're going to leave behind 5x squared plus 9. Oh, whoops, not plus 9. I'm sorry. The plus 3. I don't know what I wrote 9. Oh, sorry. It was right. I was looking at the wrong thing. Gosh. It was right. It was 9. Because I copied this 9 down. I was looking at the 3. Now, if you remember learning distribution before, so what happens is that we are, to double check, let's look at the check. We're going to multiply everyone here by the first term and everyone here by the back term. So 5x squared has to multiply 5x plus 3, and 9 has to multiply 5x plus 3, right? If we're multiplying the first term to the front and the back, which gives us pretty much our last problem. If I distribute this, it'll be 25x cubed plus 15x squared plus 45x plus 27, which is our original problem. So here's our answer right here. Because this is the factored version of it. Okay, anyone have any questions about how we did this problem? The cool thing about factoring by grouping is that it takes something that obviously doesn't, it doesn't obviously look factorable. And then we take some time looking at what parts do we have in common. Now, there is actually more than one way to factor a grouping problem like this. There is more than one way. So I'm going to show you just this other method. I'm going to show you both of them actually at the same time. Whoops. Yep. Okay, so this is a huge one. So I want you guys to go ahead and break it apart right now. I want you guys to do this yourself. Factor it up. And then I'm going to show you a slightly different order that I'm going to do right now while you guys work on that problem, okay? Okay, hopefully you got the same answer as I did. But let's go ahead and go through what you guys did. 3 and 9 and 3 is a 3. X, the max I have is x to the 4th. Whoops. X to the 4th. Oh, I can factor this again. One more step. That's going to be, I see a 3, it'll be 3x squared left over x plus 1 and x squared plus 2. Okay, I can factor that one more time because we had a common 3 here. Right. Take out what's in common. I have a 3x plus 1 left over here. Oh wait, well, I messed up someplace. Oh, this is a 3 here. There you go, 3x plus 1. Sorry, I lost my 3. 3 times 3 is 9. In the back, looking at 18 and 6, that's going to be a 6. I have a 3x and x squared in common. 3x plus 1. I have a 3x plus 1, 3x plus 1. 3x plus 1. Left over 3x to the 4th plus 6x squared. Looking at this, I also have values in common. So I want to make sure I continue the factoring. That's 3x squared left over x squared plus 2 and 3x plus 1. Okay, so both methods in the end end up with the same answer. So one thing is that the order doesn't super matter, but you have to make sure you do find like terms. Okay. I would say which one's easier? The way it's written. That's easier. But I'm just saying that it's not. You're not always limited to one set of operation, one order. That if you find other group parts are related, other groups are related, you can try that too. The goal is that once I factored out the common values, what's left over is exactly the same term, right? This is exactly the same term, so we can factor it one more time. If they're not the same, then it probably isn't factorable by grouping, or you have to try a different order. Okay, let's do one last one, okay? And we'll call it. So this one looks a little terrible, but this one has multiple variables, not just one variable. So 12 s squared r plus 16 sr plus 30 s squared minus 40, sorry, plus 40s. Okay. So let's see what's in common in the front. 12 and 16. I have in common a 4. I see a common S and an R. So S and R. What we have left over in the front is 3S plus 4. Take a moment and make sure that does make sense to you. I took a 4SR from the front and a 4SR from the back. 4SR from the front and a 4SR from the back. Let's take a look at the back. 30 and 40. So what we have in common is for sure a 10, right? 10 and an S. So we have leftovers 3, S plus 4. Now here's the hint. You should end up with the exact same factor in the back. If I have 3s plus 4 in the front, I better end up with 3s plus 4 in the back if this is factorable by grouping. Because we're going to take these out, and I'm going to stick them in the front. 3s plus 4. What's left over? We have 4sr plus 10s. Let's double check it one more time. I see 3s plus 4. There's no common term in 3 and 4s, 3s and 4. But there's a common term s here, and a 2. 4 and 10. We can common factor is 2. So I can take that out also. So we have 2s left over, 2r plus 5. And we have 3s plus 4. Now, just to point out a hint, is that we see this 2s here in the front. If we have something that's hanging out in the front, it turns out that was a common factor at the beginning of the problem. If you look up here, all these have a 2s, 12s, 16s, 30s, 40s. We could have factored out the 2s right at the beginning of the problem to make our lives actually a little bit easier, ever so slightly. But again, all these factors will always reveal themselves no matter what order we factor it. And one more. I said that was the last one, but I had one more thing I need to show you guys. Here is a issue where you have a negative. Okay, here's a negative problem. If I write 9h squared, cubed plus 9h squared minus 5h minus 5. Now, I'm going to give you an idea here that you know you have to factor out a negative when you see something like this. So let's go ahead and just stick to our guns. We're going to take out what's in common. That's a 9h squared left over h plus 1. Now, if you look at the back, you see that they both have a common 5. Now, if I just took a 5, okay, just watch so you don't need to copy this part. If I just took a regular 5 here, we have negative h minus 1 behind. Now, do these terms match up? They don't. Now, this is the issue. Sometimes the signs don't match up. If the signs don't match up, that means you had to take out a negative so that the signs do match up. You have to force them to match up. So I'm going to go ahead and rewrite this. I'm not just going to take out a 5. I'm going to take out a negative 5. And if I factor a negative 5, that negative h becomes a positive h, and that negative 5 becomes a positive 1 when I factor it out. So the key thing to realize here is that I need to bring that negative with me. If the terms don't match up because of the signs, it's because you need to factor out a negative. And then we have our common h plus 1 now that we can factor out, and we have left over 9h squared minus 5. And I can't factor out anything else, so we're good.